These are the frequently asked questions for the review of sections 4.6 to 4.8 in Algebra 2 for day 1. Starting with number 8, remember when we're working with I and we have to perform operations of addition, subtraction, multiplication, or division, we first just think of them as if they were an X. So in number 8, we're going to do FOIL on that. So first times first, 2 times 8 will give me 16. Outside times outside, 2 times negative 5i will give me a negative 10i. Inside times inside, 3i times 8 will give me plus 24i. And last times last, 3i times negative 5i will give me a negative 15i squared. Then we would combine like terms. So we're going to take negative 10i plus 24i, which will give us 14i. And as we're writing down negative 15, we should remember that I squared is negative 1. So this is really 16 plus 14i plus 15, which will be 31 plus 14i. And that is in standard form, so we don't have to do anything with that to move any of the terms around. Everything should be good. Then in number 9, I want you to try to avoid that most common mistake made in mathematics. You look between these two complex numbers and you see that this is subtraction. So go ahead and drop the parentheses from the first set, the first complex number that you see there, and then just distribute that negative through the second set of parentheses. Then you can combine like terms. So we have 2i minus I, and we have negative 3 minus 6. And again, we want the real part in the front. So that'll be a negative 9 plus 1i. And that will be that complex number in standard form. Then number 10 requires rationalizing the denominator. So the first thing we do is come up with that complex conjugate, and that has to do with the denominator, and all we do is change the sign between the two to create that difference of two squares pattern that will eliminate the middle terms for us. And then again, I always start with my denominator and make sure things are going to work out nicely. So first times first would be 4. We don't need to bother with outside times outside and inside times inside because those will cancel each other out. Last times last will give a negative I squared. And that's going to be 4 minus a negative 1. And that's 4 plus 1, which is 5. Then in my numerator, I have to go ahead and use FOIL. So first times first will give us 8. Outside times outside, 4i. Inside times inside, 4i. Last times last, plus 2i squared. Then go ahead and combine like terms, 8 plus 8i, and recognize I squared as negative 1. So that will really give us 8 minus 2, which will be 6. So we will have 6 plus 8i over 5. And again, if we're supposed to write our answer as a complex number in standard form, think of it as dividing both of those pieces, the real number piece and the imaginary piece, by 5, and then tack that I on in the back. So it is in fact A plus BI. On the next page, let me get this opened up a little more. Number 15 says solve the quadratic equation. Doesn't give us a method, but I'm going to take this opportunity to get you to practice your completing the square methods a little bit. So I'm going to move that 3, that C value that's not a perfect square, over to the other side. And then complete the square by using that little b over 2 squared formula. So we have negative 2 divided by 2 squared, which is negative 1 squared, which is 1. So I need to add 1 to both sides of this equation. And that has created a perfect square trinomial. On the right-hand side there, negative 3 plus 1 is just negative 2. But in the parentheses, that's always going to be x and then b over 2. Well, b over 2 was minus 1. So we take the square root and we get x minus 1 equals plus or minus, because whenever we physically write that square root symbol down to solve, we have to use the positive and the negative. and then that will be I square roots of 2, because the square root of negative 2 is the same thing as the square root of negative 1 times the square root of 2. And then we would go ahead and take the 1 over to the other side. And if we are to write this answer in standard form, that means the square root of 2 has to come before the I. Just make sure that it doesn't look like your I is underneath the radical symbol with the 2. So completing the square with that one. And then number 16, x squared minus 8x equals negative 6. Make sure I wrote that down right since I had to scroll up. All right, I'm going to do the same thing. I'll just take this as an opportunity to practice completing the square. Now, we already have our c value that wasn't a perfect square moved over to the other side. So it's a matter of b over 2 squared. So negative 8 divided by 2 squared would be negative 4 squared, which is 16. So I need to add 16 to both sides of this equation. And what I've just done is created a perfect square trinomial on the left-hand side. And that's going to be x and b over 2. So negative 8 divided by 2 gave us a value of negative 4. Then we'll go ahead and square root both sides. So positive and negative square root of 10, and then add 4 to both sides. So x equals 4 plus and minus the square root of 10. So 2 solutions for our quadratic there. On the next page, it says evaluate the discriminant of each equation and how many real and imaginary solutions does each have. In 21, if we're going to use the discriminant, we have to first make sure that it's set equal to 0, and our quadratic is set equal to 0. Remember, it's ax squared plus bx plus c, so a is 1, b is 6, and c is negative 7. So now what we need to do is the discriminant, which is just b squared minus 4ac. So that's 6 squared minus 4 times 1 times negative 7, and that will give us 36 plus 28, which is going to be 64. And 64 is a positive number, so that means that this one will have 2 real solutions. 2 real solutions. In fact, it's a perfect square, which means that was factorable. And of course, you take a second look at it, you realize you could find 2 numbers that multiply to negative 7 and add positive 6. So we wouldn't have much trouble finding them. All right, number 72. I had to stop there, a little interruption. We have 4 plus the square root of negative 25. And you can see right away that is not simplified. The square root of negative 25 will be 5i. And that's because the square root of negative 25 would be the square root of negative 1 times the square root of 25, which would be I, and then a 5. But again, we always put it behind it, so it will be 5i. And then the square root of negative 100, well, that's not simplified either. Obviously, we're going to have a 10i from that one. So what we have to do is go ahead and distribute that 10i. We're distributing it from the right, and 4 times 10i will give you 40i, and 5i times 10i will give us 50i squared. So we have 40i plus 50 times negative 1, because I squared is negative 1. And then we would go ahead and reverse this so that it's in standard form, negative 50 plus 40i, a plus bi for our standard form. Similar in 73 in that we have to simplify this before we go ahead and do any math and take a peek at it. So we've got 2 square root of negative 24 plus 6. So the square root of negative 24, we're going to have the square root of negative 1, and then we need the largest perfect square that will go into 24 evenly. So you do a little bit of checking. It doesn't take you long to realize that that's going to be 4. So this would be I and a 2 and a square root of 6. So that's probably the biggest part of this problem, is just getting that separated. So now it's going to be 2 times, we reverse these 2i square roots of 6 plus 6. Well, that's going to be 4i square roots of 6 plus 6. And if we're going to put this in standard form, we'll put the 6 in the front. So 6 plus 4 square roots of 6 I. And again, make sure that your I does not appear to be underneath the radical as you're working through that one. Then number 76, I showed you this one. I showed you one a little bit earlier where we were multiplying, but I want to make sure that everybody has that down. So the first thing I did was I looked at the problem and made sure there was no addition or subtraction in between the parentheses, which means I'm just supposed to use FOIL on this. So first times first would be 3, outside times outside would be 2i, inside times inside would be a negative 27i, and last times last would be a negative 18i squared. So we would have 3, and then 2i minus 27i would be a negative 25i, and negative 18 times I squared is negative 1. So we're really looking at 3 and 18 because a negative and a negative will produce a positive, so this will be 21 minus 25i, and that is a complex number in standard form. Then, number 77. And I will rewrite this one down here where we can see it. It is the quantity 3i squared, and then that is minus 3 times the quantity 1 plus 5i. So a couple things to watch out for here. First, when you're squaring that 3i squared, remember what you're doing is really writing that down twice, because that's what squaring means. The closest thing to its left is the parentheses. We need the whole term squared. And then when you distribute that negative 3, make sure that you take that negative sign along with. So in the front here I have 9i squared, and then I will have negative 3 minus 15i. And then of course I squared is negative 1. So we will have negative 9 minus 3, which is negative 12 minus 15i. And that should be it for this first day of review.